So Math 2 students, this is the last video, the putting it all together video in your Pacman for Polys video. And in this video we're going to do several different things. We're not just going to raise a power, to a power, multiply, or add. We're going to do all of them in one problem. So take a look at number 1. What you'll notice is we've got division going on, some multiplication going on, and we're also raising to a power. So the first thing I'm going to do is I'm going to raise this monomial to the power of 2. Remember, when I do that, I multiply my exponents. So this 2 has an exponent of 1. 1 times 2 is 2. The a has an exponent of 3, so I'm going to multiply 3 times 2 and get a to the 6th. My exponent here for my b is b to the 1st, so that becomes b to the 1 times 2, or b to the 2nd power. And the exponent here of c is negative 2, so negative 2 times 2 is negative 4. I also need to raise the denominator to the power of 2, so I need to take 5 to the 1st and multiply 1 times 2 and get 5 squared. A to the 1st becomes a to the 1 times 2, or a squared, and b squared is 2 times 2, or b to the 4th. So what you'll notice is I've successfully raised to the power of 2, but I've got some negative exponents to resolve, and I can also call 2 squared 4 and 5 squared 25. So let's fix those things right now. 2 squared is 4, a to the 6th, b squared, but c needs to cross the line and change the sign. So I'm going to write it in the denominator and change the sign of exponent. 5 squared is 25, a squared, and b to the 4th. So in this step, I've gotten rid of my negative exponents, and that's a good thing. But what I notice now is that I'm dividing, and I've got an a term here and an a term here, b here and b here. So the rule for division is when we divide, we subtract our exponents. So I have 4 and 25, a to the 6 minus 2, b to the 2 minus 4, and c doesn't have anything in the numerator, so I just leave it right here in my denominator. Let me scoot this up so you can see what I did. A to the 6 minus 2, b to the 2 minus 4, and then c stays right where it is. So let's do this subtraction. 4a to the 4th, b to the negative 2, over 25 c to the 4th. But notice now that in dividing, I've introduced another negative exponent that I need to take care of. So I'm going to cross the line and change the sign. And my final answer is going to look like that. Let's take a look at one more putting it all together problem. Notice the b here in the numerator is written with a square root symbol, but we know that the square root of b is the same thing as saying b to the 1/2 power. So I'm going to write that without the square root sign. I'm going to write it with a rational exponent. So this is what we're ultimately dealing with, and since we're dividing, we want to subtract our exponents. So I get b to the 1/2 minus 1/4, which is b to the 1/4. Now, the instructions say leave your answer in exponential form. There is another way to write this as the 4th root of b to the 1st power. But because the instructions say to leave the answer in exponential form, this is going to be the answer that I choose for this problem. Let's take a look at problem 3. It's the last problem in our putting it all together. And we notice we have x to the 9 halves divided by the third root of x, which can be rewritten as x to the 1/3 power. And again, when I'm dividing, I want to keep my variable and subtract my exponents, so I end up with a problem that looks like this. B, or not b, but x to the 9/2 minus 1/3. So now our problem is simply to subtract these two fractions. And to do that, I'm going to have to get a common denominator of 6. So I have 27 over 6. I just multiplied my numerator and denominator by 3. 3 times 9 is 27, and 3 times 2 is 6. And then to get a denominator of 6 here, I'll have to multiply my numerator and my denominator by 2. So I have 27/6 minus 2/6, and I have x to the 25 over 6. And that's the answer to problem number 3. Again, we could rewrite that as the 6th root of x to the 25th power. But our instructions say to leave our answers written in exponential form. So this is the answer that we would choose for this problem.